Oh, g'day champions. That's my favourite. Mesa. Yay. Got a Studio 22 here. Complaint of crackling, etc. Sitting for a while. General cleaning service. But we all know Mesas always have a few little secrets up their sleeve, don't they? So she's looking a bit dirty. Needs a good old clean. But it's what's inside that counts. So it's from the Caliber series. Ignore the Class A. That's all horse shit. Marketing crap. It's not Class A. It's brought in by Pro Audio. I remember Pro Audio. I bought some stuff from there back in when I was in high school. I bought a Marshall Quad Box 1960A. Don't judge me. And an LTD M1000 with a Hiscox case. And I've still got them all but the quad. I've got another quad, but same shit. Anyway, moving on. It's got the vintage Black Shadow. I believe it was, for a while, Celestium was making them and Eminence was making them too. I'm not sure. Mesa Boogie don't make speakers. They just get OEM badging on other manufacturers' gear. But they were pretty good speakers. I didn't mind them. I had the 90 watt one in a cabinet for a while, and it was wasn't bad. Didn't mind it. Anyway, I'm just going to avoid the foreplay and get the chassis out and have a look at the horrors within. Alright champions, say hello to the world's stupidest valve retaining mechanism and the world's dumbest output transformer securing method. It's got a wooden wedge just shoved in there with a bit of silicon. In this case I don't think there is any silicon actually. It's got two little holes cut in it, little notches for the wires to pass through. I never get tired of it. So this has already broken off its little proprietary support things there, and someone's used some cable ties to keep the thing held down. Okay, so this used to be the springy ones on this side then, so we've got to be careful that we don't break the ones at the back. And we got away with it. So I don't know if you can get them anymore. But previously it had ones at the front which acted like little hinges, but you're using like hot plastic as a hinge. What do you think happens? It snaps. And that's obviously happened in this case because they replaced it with some cable ties. So these things love to cook their EL 84s, yeah, as you can see with the white logo there. For some reason, all the manufacturers, Mesa in particular, but I'm also looking at you, Fender and Marshall and Vox and everyone else, they seem to, in particular with EL 84s, just completely ignore the, the ratings of the valve on the data sheet. I think it might all go back to Vox and the way that they ran them in cathode bias mode, like well over spec. So you get like max maybe a year out of the valves before they're proper cooked. But that's in cathode bias. A lot of these manufacturers run them in like 160% in fixed bias, and when you play, the bias goes through the roof. That's just quiescent, 120, 130, 140, 150%, which is ridiculous. So you just cook them in no time, and you can see there from the logo these have got way hotter than they were designed to. On the other one not as much, but you can see it's starting to go there in the corner as well. So this one you can actually see the heat marks around the valve there, where all the shmoo that's collected on the chassis is actually burned as well. But I can see through the vents. I'll just zoom in, see if you can see too. Someone's played knifey spoony before, because down in here you can see a few metal film resistors. Replaced the stupid carbon composite ones. So it looks like two of the bias feed resistors. What else we got? Got 470, so that's screen grid resistors there, 470 ohm 2 watt. We got some 1Ks down there as well. Not sure what they are. 100Ks, maybe some of the plate loads have been replaced. But we're still seeing original caps. We've still got the original metal film stuff in the front end. And you still got the silly orange drops down there as well. So there looks to be some discoloration in the board, but let's flip her over and have a look. I'll just remove these valves first. You can see how much the board moves around in these things because of the silly plastic standoffs. Mesa are not quality amps. Sick of people pretending they are. They cut every corner they can. Yeah, with dire consequences. Anyway, it keeps me in business, doesn't it? Suppose I shouldn't complain too much. Alright, and here she is, the non-serviceable amp from hell, because you got to desolder everything to flip the board to know what you're even dealing with. But you can see all the discoloration on the output valves there from the the design, where all the heat comes up straight into the board, and they run them way over spec. I honestly think that they don't understand that there's a difference, like they are ill-informed after even this many years in the trade, that you're supposed to only bias a cathode biased amplifier at about 100%, whereas they tend to bias the fixed bias ones, and then when you actually run them, they run way hotter. I literally think, because how many times can they make the mistake before you start assigning either malice or incompetence? I don't know. It's not just a mistake anymore. They keep doing it. Now this is an older amp, but they still do it on the modern amps, so that's why I said yay earlier. So looking down here, some individuals replaced the ground cap, which is not required because we have 3-pin plugs in Australia, but the whole point of these is when you have a 2-pin plug in the US, you got a 50% chance which way you put it in. So if it's noisy one way, you attach the AC ground to the active and it might go quiet, or if it doesn't, you attach it to the neutral because that's what's actually plugged into the active and it might go quiet, but there's no actual, not supposed to be any galvanic connection between either of them and ground. And this cap basically shunts the noise on the line to ground, or it creates an AC ground essentially. It ties one of the leads to ground. Now if you do have to have one in the States, you guys that still have the 2-prong walls or whatever, having your next 2 class cap is what you want. A safety rated cap with all the crazy printings on the side there of the different safety ratings. Don't just be putting a poly or an orange drop in its place. A main suppression cap that's approved for the application and rated for AC, not for DC. But anyway, we don't have any requirement for this in this country because we all have 3-pin plugs, as you can see here. Alright, so everyone knows that messes are a pain in the ass to work on and we have to charge more as a result. Part of that reason is that you can't work on the things. You've got to desolder stuff. There's no connectors or anything. You've got to desolder stuff to be able to flip the boards up to be able to access the component sides. You can't test them while they're running a lot of the time while it's apart. You have to actually put it back together at least to some degree before you can determine if your replacement parts or whatever have actually addressed the issue or not. You need to desolder some wires in order to flip the board, and you can see here someone else has done that, but in the process you can only solder and desolder these so many times because it's a very low quality PCB. They are through-hole plated and double-sided, but the pads are tiny and they're not suitable for rework. It's meant to be built once and that's it. If it fails, they haven't offered any thought into repairability at all, and they still don't. So you can see here the pads have been ripped off and the connections to the output transformer there. So we're going to have to be very careful in this area. We may have to replace it with turrets. There's enough slack on the leads there that if we had to connect them to the top and put some turrets there, we could do that. And there's enough room around them in this area, and then we could run wires to the next pad. And that would offer a mechanical connection that's reusable more than once or twice. Okay, so the first thing that caught my eye is a lot of these. This is like an unpopulated area for probably, I think, for the EQ. If it was one of the models with it, they use the same board for several amps, and there are cutouts in behind this section for the graphic EQ. So this is probably part of that circuit, but it looks like parts have been in there and then they've been pulled out, because that's what it looks like from the other side when you basically pull a component out without heating it through. But I'm not sure, they might just be air bubbles. I've never seen that before. That's really weird. It almost looks like the parts have been pulled out from the other side. But why would you? But I am spotting it in some other positions next to the actual lead, so maybe there was some contamination on the board when they were soldering, or in the solder, on the solder surface, something off-gassing while the solder's trying to cure, and that might have led to those bubbles coming out. So here's another idiotic thing that Mesa always love to do. They love to use this, it's almost like braid, well, it is braid, to connect all their grounds, including where it can easily just get pushed down and touch other stuff. Take your pick, so you have to like pull that up. What I like to do is put a bit of heat shrink around it and just leave the very tip exposed before reassembling. Now I've seen these repairs so often that I've kind of, part of me in the back of my head thinks they're just a standard Mesa assembly technique, but someone's put some link wires there because these traces love to just vaporize themselves. That one and that one in particular. So you almost every one of these amps that's made it this far has like some sort of bus wire or addressing of that issue there. Oddly enough, the boards can look incredibly scorched and they still don't seem to conduct even at like 1000 volts with the Mega, even with heat applied. So as bad as they look, at least they got the fiberglass resin correct, which is more than we can say for Marshall and their JCM 2000 series, but that's another kettle of fish. You got the reverb just hanging off the back there. These wires love to break because they're rocking around all the time, especially in transport, so we'll double check them and check that we've got the correct DC resistances that we expect. You've got the world's largest ground bus there, which is really weird because they seem to just despise service techs, but then they offer you this big thing there to connect your hook to, which is nice of them. So we can't tell a lot about this thing from just looking at it like it is, so what I might do is gingerly fire it up. I can't do it any other way because I am a ginger. And we'll take some measurements. We know what the valve pins are. We can follow the traces and know, you know, that's your plate load, blah, 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 blah. And we can see if we can pin down where the noise is coming from, or if we've got leaky caps, that kind of thing, and just see if there's any excess current draw anywhere, or you also see what those valves are doing, the EL84s, if they need replacing, just to get an idea of what this thing's going to cost so we can flick them a rough estimate. Messes, I always chuck a percentage on top, sometimes up to like 50%, just because there's always other stuff that pops up, and if it doesn't pop up, well, happy days, I don't charge a customer, but if it does, at least they know what to expect there. There's no nasty surprises. I mean, who's ever upset when they come to pick up their amp and it costs less than the quote? No one. But with messes, you just always got to have that margin there, because there's almost always other stuff that pops up that you couldn't have foreseen, because it's so hard to assess when they're in this condition without spending an inordinate amount of time. More Mesa art in engineering time. So when you got the amp on the bench sitting this way, which is probably how it was designed, the reverb tank misses that board, but a bit of vibration. You can see it's been rubbing on the board there, so this thing's rattling around like crazy. Sometimes you get multiple holes down here, so you can change the angle of it and stuff. You see that on the inside of oh, here we go. Straight away I've got a broken wire. So that's the ground. That just connects the body of this thing to ground, so no biggie, we can reconnect that one. But yeah, sometimes you get multiple holes down there, so you can change the angle from the springs and the tension, but in this case there's only one set of holes, so that'll rock around and rub on that during transport, but not a hell of a lot we can do about that. And part of the reason I don't like these foam retainers is because eventually, and the valve tips do vary in length, some of them can reach through and crack themselves on the alley with vibration. You can see they punch their way almost all the way through there, and that's the preamp valves. For the output valves, they heat the foam up and degrade it and make it go hard and stiff, and see it cracks like that. So that's really got no spring to it. It feels like pushing on like expander foam. It doesn't spring back, so that's all cooked. Just turns to ash. Not a good way of retaining valves, just to say the least. But what do we expect from Mesa? I suppose it's lasted this long, but yeah, we'll probably have to put some neoprene foam or something on that. Otherwise, just leave it off entirely and rely on the valve sockets to do their retaining. Alright, champions, so I checked her over and did a quick test on the variaxles, make sure nothing catastrophic was happening. Bear in mind the customer was using this right up until the moment he decided to bring it in, so it's not like there was any you know, major issue with it other than just scratchy operation. So we'll fire it up. We're drawing about 53, 54, 55, 56, about 50, stabilizing it around 58 watts from the wall. Got 400 hertz going into it just to satisfy your little ear holes. So that, I don't know if you can hear that, but there's a real thumpy sort of weird noise on that pot, so I think we've got DC on that pot. Just have a quick look. On the master we've got 2.8 volts going up to 25 volts. So we've got DC on the master, quite a bit of it. The other pots are scratchy. But yeah, we've got a major issue. Major issue with that master volume. We've got a leaky cap or something there, so I'll just turn that pot all the way up so it doesn't do any damage. What else have we got? Reverb. Reverb's working. Hard to tell the presence because we haven't got any haven't got any harmonics with a sine wave, but Alright, so some of those pots might come good with a bit of cleaning, but that DC issue on the master there is probably a leaking cap issue. So I was just watching the power then, she just shot up through about 100 watts. So from the wall. So something's running away on the output stage. I was watching it and then just all of a sudden it shot right up. So I think we've probably got a leaking phase inverter output coupling cap that's dragging up the grids. But let's confirm that for realsies. Alright, so depending on the amp design, a pretty quick way to test if the coupling cap's leaking is just, I'm on the EL84 grids here, the control grids. They'll fire on the standby, which means there'll be plate supply to the phase inverter side of the coupling caps. You can see that voltage changes. Initially, not too bad, but then goes almost to nothing. And she'll be running away at that point. There is a possibility something else is happening in the bias supply, like a breaking down voltage divider resistor or something like that. Let's see what's on the plates momentarily. 420, 30, yeah, as it goes up. So there's about 420 volts there unloaded on an EL84, which is rated for 300 volts maximum. Sure, a lot of amps like push it to like 350 or whatever, but over 400, like 420, 430 is just ridiculous. Some amplifiers I've seen as high as like 460. Just asking for trouble, man. What's the point of having magical tone pixies of, you know, ridiculously high voltages if you just keep blowing up valves? Alright, so I think for this one I'm going to quote a recap because the caps are date coded at 1986. We're sort of getting to the point where we probably want to replace them if they want longevity. And because removing this board is such a rigmarole, it makes sense to do everything at once. In the process I want to replace the tantalum capacitors because they love to go short circuit, because this is not a this is not a regulated power supply, and when you use them in cathodes of valves, if that valve ever goes short circuit, it's going to deliver more than the rated voltage to that tantalum. Electrolytics can probably put up with it for a little while, whereas tantalums just go hard short. And you'd have to remove that board, or at least try and drop it out from this side and try and somehow get the component back in from the, or mount them on this side, which is what a lot of people do. I prefer to actually pull the board, do it properly, rather than try and mount or piggyback stuff on the back here and just drop the component down through. I like to try and make it look like, you know, the stock amp, even though it is a Mesa. So we'll factor in that recap. We'll replace the film caps that are leaking. Make sure that there's nothing else that could be causing those fluctuations as well. We'll factor in a bit of extra just in case something does pop up and we've got to remove the board again, or if we've got to replace some pots on the front panel, that kind of thing. Just add a bit of a margin there, so you know, if other stuff goes wrong, then fair enough. And a new set of EL84s, because when they look that cooked, they're not long for this world. Replace the foam valve retainers, and whatever else I can think of. So again, if this one gets approved, I'll see you in part 2. Otherwise, it'll be members only. So rock on, legends. See you on the next one.